Hi, I'm Jordan and I'm a student at 42 Adelaide, and today we're going to be talking about structures and how to manipulate them. So far you've been introduced to a lot of simple data types in C, like integers and characters. Let's look into a few more complex types. You've most likely already used arrays, but we're going to go into a little bit more detail before we take a look at structures. So an array is just a series of variables that are all the same data type, stored contiguously in the memory in your RAM. We can create an array in a number of different ways. And here's a simple int array made with 42 memory locations. So we'll just start with our main function. Oops. And all we're going to do is we're going to declare an int, and we're going to call it my int tab, and we're going to give it 42 memory locations. So when we create the array, we don't know what's stored inside each variable because we haven't initialized them yet. So let's do that now. What I'm going to do is I'm going to create another integer here, not an array, just a regular integer, and we'll call it a. And when we create a new int, we can store the values inside of our integer array into this array. So what I'm going to do is I'm going to say a equals my int tab 21. So basically what that's doing is it's going to take what's stored in the array at location 21 and put it into a, and we can use that just like we do any other variable. So if I add 1, it's just taking what's in my int tab at location 21, adding 1 to it, and storing it in a. We can also put things into different locations in our array. So I can say my int tab 0 equals 3. And we can get as complex with that as we like. So I can say 3 times a plus 5. So it works just the same as storing it in any other variable. Note that I'm using index 0 here. That's because when we are using arrays, we start with the index 0. So we've got 42 slots in our array to put variables. So the last variable in our array would be number 41. Another array that you've already seen in C that you probably wouldn't have even thought of as an array is the implicitly created string. So something like hello. So when we put the string in double quotes, it creates an array of the total number of elements we've got in the string, 5, plus the null terminating character. So 6 total is our null terminated string there. So each value in the string is 1 byte, followed by the null terminating character, so 6 bytes total. We can also access arrays using pointers in the same way that you can access a string. So if I wanted to create an integer pointer, which we'll call p, I can use that to store different values in my array. So if I say p equals the memory location, the reference of my int tab location 0, that's going to point p at the very first index of my array. So now it's holding whatever is stored in that first location in A. Then what we can do is we can assign a value to p directly. So say pointer p equals 1. So now the very first location of my int tab, so index 0, is storing the value 1. And we can change that again, if we want to, by using the index of our array. So I can say my int tab location 0, the first location in our array, equals 100. So now what was a 1 in that first location has been changed into 100. So it's important that you know how many elements are in your array. So we've stored 42, but it's important that we remember that, because unlike with the implicitly declared string that we used earlier, there's no null terminating character. So we need to know exactly how many locations in memory we've created. And remember that even though pointers have similar behavior to arrays, they're not the same. When you create a pointer, it's not creating multiple locations in memory, it's just creating one single one. Whereas with an array, you can straight away declare how many locations in memory that you want to use. So the opposite also works. If we have a series of elements referenced by a pointer, we can access them using the array syntax. So if I create a character array here, which we'll call S for string, I can say S equals hello 42. So now our S pointer only holds the address of the very first character in this string. So the H at the beginning of hello 42. If we want to change it to a different area of that array, we can use S++, which will move it along to the E. We can also do that using pointer S plus 1. And that does exactly the same thing, it just moves it onto the next element of the array. If we wanted to write a different character using our array, we can access the element in any of the ways that we've talked about. So if we say pointer S, that does exactly the same thing as S0. It's just accessing the very first element of the array. If we want to access a different element of the array, we can say pointer and then S plus 2, which will access the third element of the array. So remember that we start at 0, so S plus 2 will get us to the third. And similarly, we can just say S2, and it'll get us to that third element of the array. Okay, now that we have an idea of how arrays work, let's move on to structures. Okay, so arrays allow us to store groups of elements of the same data type, which is cool, but if we wanted to store different elements of different types, we would have to use a structure. So what if we needed to have a data type that can store, say, an integer, 2 characters, and a long? How would we accomplish this? There isn't any standard C type capable of doing this, so we need to create a structure. So I'm going to make a new file here. Okay, so just like any other type of variable, we have to define it first. So what we're going to do is we're going to say struct, and then we'll give it a name, which is going to be S my group, and then we need to put some data in there. So let's say we're going to put in an integer, 2 characters, and a long. Like I said before, we'll start with int. We'll just call it A, char, C1, another char, C2, and long, which we'll just call L. So now we've got A, C1, C2, and L, and they're all members of our new structure. As you can see, this definition is made outside of any functions, and is very often stored in the include or header files, which you'll need to learn a little bit more about for this topic later on. When you define a structure like this, it isn't reserving any space in memory. That will have to be done when we assign a new variable of this type. At the moment, we're just telling the compiler that this is a kind of data that exists. So let's make a new variable of this type. I'm going to make a new main function. And we will declare a struct of the kind we've just made, struct S my group, and we'll just give it a name, my elements. So we've used the keyword struct, the name of our type, and then given the new variable its own name. And this isn't just a one-off, we can create as many of these as we want. So I can say struct s my group, same type as before, and we'll call this one my elements 2. So now memory has been reserved to store each structure. And now let's go ahead and assign some data to it. So I'm going to say my elements dot C1 equals 1. So basically what we've done there is we've taken the value 1 and we've stored it inside C1, the character inside of our struct. So the dot character is used to separate the name of the element, the name of the struct that you've created, the name of the variable inside the struct, and then you can just assign it like that. And that works exactly the same way as just any other data type. So let's make an int, which we'll call A, and we'll say A equals 2 times my element dot A plus 8. So basically we've just taken whatever was inside of our struct, inside element A in our struct, multiplied it by 2, added 8, and then stored it in the new int that I've made that's called A. So we can use the same name inside of our main function that we've used inside of the struct because they're declared differently. The two structures we have made have their own RAM space and unique variables. So just like any other two variables we make. So myElement.a is completely different to myElement2.a. It's possible to get the address of an entire structure and manipulate the different members of the structure using a pointer. So let's make a new structure pointer, which we will just call SP, structure pointer. So we want to store the entire struct within the pointer. We can say SP equals the address of my element. And if we wanted to change the element that was stored inside of SP, we can say pointer SP dot C2 equals 42. Just store 42 inside of character 2 in our struct. And we can also access it with the int we've made earlier. So we can say A equals 21 plus pointer SP dot A. So as you can see, when using pointers, it can be a bit confusing to remember how to access the data in the struct because of the syntax. So instead of using the dot, we can also use a special arrow syntax to indicate that we're pointing. So if I said SP pointer A, so that's the same thing. Just because we're using a pointer, we can now say SP pointer A, and that's the same thing as if it wasn't a pointer if we were using the dot. And that's also the same as saying pointer SP dot A, exactly the same thing. Okay, so structures are not just limited to basic data types like I've been using here. So let's see what else we can store inside of one of our structures. So if I made a new struct called my S1, I can put inside an integer, just like we did before. I can also put inside a character array. And I could also put in an int pointer if I wanted to. So we can mix and match data types as much as we want to inside of the struct. So here we've got the integer, character array, and the integer pointer, and they're all members of the exact same struct. Let's make another struct. And this one, we're going to see that we can store structures inside of structures. So just like before, we can put in whatever we want. It doesn't have to just be structures. We can say int b to start with, and then I'm going to store a member of the structure that I've just made inside of this struct. So I'll say struct s my s1, and we'll call this s1. A structure can also have a reference to itself inside of it. So I can say struct s my s2, and we'll call that one s2. So it's important that this is saved as a pointer, because you can't initialize a struct with itself inside of it, because that will just cause an endless recursion loop. But it's fine to have a reference to your structure within itself when you're declaring it. Okay, we've covered arrays and the different ways that you can access memory in them, and we've covered structs. That you know that you can store different data types inside of them, you know how to declare them, and you know how to access the data inside of it. So that's pretty much all I've got to talk about in this video. So thanks so much for watching.